Okay, so I do apologize about the technical difficulty. The first time I recorded this, it didn't upload, it wouldn't save, it was kind of a hot mess. But so I still want to walk through notes with you, even though it's already filled out on my paper. So that way a few things can be explained, and that way hopefully it clears up any questions that you have. So vocab words, first and foremost, this form, so when you have an x squared term, it's called a quadratic. So this is the general form that we're going to be using. Again, a cannot be 0, because if a is 0, then you don't have an x squared term, which means it's not a quadratic. Okay. And when it is in this form, so when it starts with your x squared term, and then you add the x, and then you add the number at the end, this is the standard form of a quadratic. So just like we talked about standard form of a polynomial last chapter, where you start with the highest exponent and work your way down, it's the same idea. The simplest form of a quadratic function is f of x equals x squared, or y equals x squared. This is called your parent function, okay? So your parent function means it's the original function that you're going to then take and move around, manipulate, and work with. So it's the original function that you're working with. The graph of the quadratic is a U-shaped curve that's called a parabola. So it looks like a U, but mathematically it's called a parabola. Okay. The fold or line that divides the parabola into two matching halves is called the axis of symmetry. So as if you would take the graph, right, and I'm going to use this picture down here, as if you would take the graph, right, so this is your parabola over here. If you could take it and you could cut it in half or fold it in half on a certain line, so that way each side would be identical, that's your axis of symmetry, or that's where, you know, you're going to get the same thing on both sides, okay? The axis of symmetry, while we're talking about it, is a dashed line because it's not actually part of the graph. It's just something that you're identifying. The highest or lowest point of the parabola is called its vertex. So the vertex is going to be that point where it kind of comes together in the U, right? So it's either going to be that minimum. So a minimum is going to be that smallest point, or a maximum, which is going to be where it's at its highest point. The key thing I want to point out right now is that a is greater than 0. So a is positive for the graph to open up. And then when a is negative, so that number in front of x squared is negative, the graph is going to open down. And that's going to give you a minimum versus a maximum. So right here in this example, this is your parent function. So this is your original function that you're going to work with before we manipulate it and move it around. Your vertex is going to be that point right down there. That's at 0, 0. Again, we talked about the axis of symmetry. And the only other thing that I kind of picked out were 2 points on either side as to where they were located. So then example 1, identifying a vertex. So identify the vertex of each graph, tell whether it's a minimum or maximum, and then identify the axis of symmetry. So first find the vertex. The vertex is down here, and it has a coordinate point of 1, -2, and it's a minimum. So then you want to find the axis of symmetry, right? Dash line. The axis of symmetry always goes through your vertex. So wherever you have your vertex, that's where your axis of symmetry is going to go through. Your axis of symmetry is not, let me rephrase that. Your axis of symmetry in this chapter with what we're going to work with will always be vertical, which is x equals 1. Okay, so then same thing for the second example over here. Identify your vertex, -2, 4. In this case, it's a maximum because your graph is opening down, and then your axis of symmetry is x equals -2. All right, so